Okay, so this is going to be the first of 4 videos that will help us review for our Semester 1 final exam. We basically took all the topics that we've learned this semester and we grouped them into major categories. So this first category is things that we know how to solve. Now, one of the major topics in Algebra 1 is solving different types of equations. So let's start with in Chapter 2, where we learned how to solve linear equations. When we have an equation like this one, we know that we draw a line through the equal sign, and we're going to start by distributing in order to eliminate the parentheses. So when we drop down the 4x minus 5, when we distribute the 1/6, 1/6 times 6 is just 1x. 1/6 times 24 is plus 4. From here, I know that I need to get all of the terms that have an x in them together and preferably on the left-hand side. So I'm going to start by subtracting the 1x on both sides, and I get 3x minus 5 equals 4. Then I'm going to add 5 on both sides, and I get 3x equals 9. And finally, I'm going to undo the multiplication by dividing by 3, and I get x equals 3. The next type of problem that we learned how to solve was instead of having an equation, we had an inequality, meaning instead of an equal sign, we had a less than or a greater than or a less than or equal to or a greater than or equal to. So to solve these problems, we said the process is actually very similar. We would start by distributing. So 3 times 3 would be 9x plus 6 less than or equal to, and then we would just drop down the 6x plus 21. Next, I want to get all the x's together. So I'm going to subtract 6x on both sides, and that gives me 3x plus 6 is less than or equal to 21. I'm going to subtract the 6 on both sides, so I get 3x is less than or equal to 15. And then I divide by 3 on both sides, which means I get x is less than or equal to 5. Now, we said that for these problems, we traditionally graph our answers on a number line because it's an easy way to represent that there are many, many answers. Because there's an equal to, I would put a closed circle on the 5, and I would shade to the left because there's a less than. Now you'll notice there are a lot of similarities between the ways that I solve these two problems. It's basically the same process both times. There is only one thing that makes solving inequalities different than solving equations, and that is the flip-flop rule. So let's write down, don't forget the flip-flop rule, which basically says if we divide by a negative or if we multiply by a negative in order to solve, we're going to end up having to flip-flop the inequality. That is the only thing that makes these two solving processes different from each other. Next, let's take a look at absolute value problems. Just like we had equations and inequalities that were very similar, we're going to have absolute value equations and absolute value inequalities. These two processes are going to be very similar to each other. The first step is going to be to isolate the absolute value. So I'm going to start by adding 5 on both sides, and I get 3 times the absolute value of 2x minus 7 equals 9. Next, I'm going to divide both sides by 3, and I get 2x minus 7 absolute value equals 3. Once the absolute value is by itself, we're going to make 2 different problems. We call the first problem the original, meaning that everything looks the same as the original problem that we're splitting up. And the second problem, which I usually call the remix, which means everything looks the same except we make this a negative 3 instead of a positive 3. Now from here, we're going to solve each of these problems separately. So I'm going to add 7, which gives me 2x equals 10, and then divide by 2, so x equals 5. That's the first of my answers. On the other problem, I'm going to add 7, so I get 2x equals 4, and then divide by 2, so x equals 2. and that's my second answer. All absolute value problems will have two answers, and the way that I remember that is that if there are two lines, which are part of the absolute value equation, there are two answers. So, two lines means two answers. All right, let's try an inequality. You'll notice this original problem looks very similar to this original problem. The only difference here is that instead of an equal sign, we have a less than or equal to. So let's go ahead and try to solve this. We're going to start again by isolating the absolute value. So I'm going to subtract 5. I get negative 3 times the absolute value of 2x minus 7 is less than or equal to negative 9. Then I'm going to divide both sides by negative 3. And I get the absolute value of 2x minus 7, and here's where that flip-flop rule comes back, is greater than or equal to 3. Now the reason I knew to flip-flop it is because I divided by a negative number. Now from here, I see that I have a great or then. I could also have a less sandwich, but in this problem I have two separate problems. So the way that I set up a great or then is I once again make two separate problems with the word or in the middle. The first problem is the same as the original, 2x minus 7 is greater than or equal to 3. And the second problem, what I'm going to do is make two changes. I'm going to flip the inequality symbol and make the number a negative 3 instead of a positive 3. Now I'm going to solve. So just like I did for the other one, I'm going to add 7, so 2x is greater than or equal to 10, and then divide, so x is greater than or equal to 5. Or, if I add 7, 2x is less than or equal to 4, and if I divide, x is less than or equal to 2. So we have two separate answers with the word or in the middle. Now on a number line, we would graph out for that type of a graph, whereas for a less sandwich, we would graph in the middle. The last two types of problems that we've learned how to solve have been proportions and compound inequalities. So for a proportion, which looks like a fraction equals a fraction, what we're going to do is cross multiply. 3 parentheses x minus 4 equals 9 parentheses x. Now I'm going to solve this like a normal equation. So I'm going to go ahead and distribute the 3. When I distribute, I get 3x minus 12 equals 9x. I'm going to subtract the 3x on both sides, and I get negative 12 equals 6x. And finally, I'm going to divide by 6, which means x equals negative 2. Last but not least, compound inequalities. Just like these types of problems where there's absolute values come in sandwiches or great or thens, compound inequalities come in sandwiches or great or thens. This one happens to be an or. So I'm going to solve each problem separately. I'm going to subtract the 3, so 2x is less than 6. Then I'm going to divide, so x is less than 3. I'm going to add the 6, so 3x is greater than 18. I'm going to divide, so x is greater than 6. And I'm going to take the word or, and I'm going to copy it down. Now on a graph, I would put an open circle on the 3 and an open circle on the 6, and I would shade to the outside because it's an or problem. So ors face out. I hope that this gives you a good idea of different types of problems that we've learned how to solve. And I will see you later for another video where we're going to practice all the stuff that we've learned how to graph.